Good morning, everyone. My name is Miss Ayat Rabaiah. I'm your math teacher. I divided 1.2 multiples, factors, and primes into 3 parts. I'll give you the first part, the second part. Today, I'll give you the third part. In the first part, I gave you multiples, the meaning of multiples, like the multiples of 3, 3, 6, 9. Factors, I gave you the meaning of factors, which is like, if you, for example, if you take 10, 1 times 10, 2 times 5, these factors of 10. And we learned how we can find the highest common factor and the lowest common multiple. Today I'll give you something new, which is primes. Attention, give me your attention, please. Some numbers have just 2 factors. Example, here we have 7 has 2 factors, 1 and 7. Why? Since the factors of 7, we can rewrite 7 as 1 times 7 equals 7. Can you give me another mathematical statement or any 2 numbers that you can multiply these 2 numbers, positive integers, will give you 7? No, there is no numbers like that. So here 7 just has 2 factors, 1 and 7. 13 also has 2 factors, 1 and 13. Why? Since we can write 13 as 1 times 13 equals 13. Can you give me a positive integer that you can multiply these 2 numbers by each other will give you 13? No, just we have 1 times 13. 43 has 2 factors, 1 and 43. Why? Since 1 times 43 equals 43. There is no positive integers that you can multiply these 2 numbers would give you 43. Nothing like that. Now, numbers with just 2 factors are called prime numbers or just primes. Numbers with just 2 factors, these factors, one of them is 1 and the other, the number itself. Like here 7 is a prime because it has just 2 factors, 1 and 7. 13 is a prime because 13 has 2 factors, 1 and 13. 43 is a prime since has 2 factors, which is 1 and 43. Look, the first 10 primes are, start from 2. 2 is the first prime. 2 is the first prime. 3, the second prime. Since here, it's back to 2. 1 times 2. There is no 2 numbers, positive numbers, that you can multiply these 2 numbers would give you 2 positive integers. 3. Why 3? Since 1 times 3, just 2 factors, 1 and 3. 5 just has 2 factors, 1 and 5. 7 has 2 factors, 1 and 7. 11 has 2 factors, 1 and 11. 1 times 11, 11. 13, 1 times 13 is 13. 1 and 13 factors of 13. 17, 1 times 17. So 17 has 2 factors, 1 and 17. 19, the same thing, 1 times 19. So just 1 and 19, the factors of 19. 23 has 2 factors, 1 and 23. 29 has 2 factors, 1 and 29. The next number, the next of 29, 31. 31 is a prime. 33, no. 34, 35, 30, 37. 37 is a prime. Then 38, no. 39 is not 39. 40, 41. 41. Yep. Like that. So here again, numbers with just 2 factors are called prime numbers. 7 is a prime, 1 and 7. 2 factors of 7. 13 has 2 factors, 1 and 13. 43 has 2 factors, 1 and 43. Now let's take some examples about primes. Look, 31 is a prime number. Why 31 is a prime number? Since just you can write 31 as 1 times 31 equals 31. There is no positive numbers, two numbers, that you can multiply these two numbers by each other will give you 31. Now the question is, what is the next prime after 31? 31 is a prime. 32 is not a prime, since 32 is divisible by 2. Or by, like مثلا 4 times 8 is 32. It's not a prime. 33 is divisible by 3. Since 11 times 3 is 33, so it's not a prime. There are another factors. 34, I think 17 times 2 is 34, so it's not a prime. 35, 5 times 7, 35, so it's not a prime. 36, 6 times 6, 36, it's not a prime. 37, yes, it's a prime, since 1 times 37 is 37. There's no two numbers. There is no two numbers that you can multiply. These two numbers will give you 37. No. So here, what is the next prime after 31 is 37. 37 is a prime after 31. List the prime numbers between 60 and 70. Between 60 and 70, we have 60. 60 is not a prime. Between 60 and 70. 70 is not a prime. List the prime numbers between 60 and 70. Don't count 60 and 70. And also 60 and 70 is not prime numbers. Now after 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, and we don't count 70. Now 61 is a prime number, since just we have 1. Yes, 61 is a prime number. Just we have 1 times 61 equals 61. 62 is not a prime number. Since here, 62 has 2 as 1. Here the ones is 2. So here 62 is divisible by 2. Also 31 times 2, 62, so it's not a prime. 63 is not a prime, since 7 times 9, 63. 64 is not a prime number. 68 times 8. 65, its ones is 5, so it's divisible by 5. So 5 times 15, yeah? Or no, not like that. Okay, since here 65 has 5 as ones, so it's divisible by 5, so it's not a prime. 66 is not a prime, since here 33 times 2, 66. It's not a prime. 67, yes, it's a prime number, since just we have 1 times 67 equals 67. 68 is not a prime number. It has 8. It's an even number as ones, so divisible by 2, so it's not a prime. Or another reason, 32, yeah, 32 times, no, not 32, something like 2, 68 divided by 2, this is 3, 6, yeah, 30, yeah, 68, 34 times 2, 68. Now 69 is divisible by 3. Why? Since if we add 6 plus 9, it's 15. Yeah, divisible by 3. So here 69 divided by 3. This is 2, this is 6, this is minus 9, 3, yeah, 3, 9, yeah, 0. Since 23 times 3 equals 69. So here 69 is not a prime number. So here list the prime numbers between 60 and 70. Here we have 61 and 67. So here the solution is 61 and 67. Let's take the last example here. Example number 3. 73 and 89 are prime numbers. What is their highest common factor? Highest common factor. Look, here 73 is a prime number. Yep. So here the factors of 73, just 1 and 73. Since it's a prime, 1 times 73, 73. The factors of 89, just also 1 and 89, since 89 is a prime number. Now the common factor between them, is 1, just 1 is 1. Now the highest common factor, 1. So it's a rule if you have prime numbers, the highest common factor between them always 1. Don't forget your workbook, page 8, question 2, question 3, and question 4. Thank you for listening and have a good day.